Okay, let's go ahead and take a look. So lithium carbonate. So when you're looking at your solubility rules, carbonate was down here in this bottom left quadrant. So carbonates are solid or insoluble unless they're with ammonium or an alkali metal. And if you forgot, alkali metals, I told you right here, they're in group 1. Or I also listed them for you. So if it's one of those, that means that we have the exception. For that one, we're with lithium. Lithium is one of those exceptions. So that means this is where we end. So your answer should be aqueous or soluble. The next one, calcium nitrate. So nitrate is one of those that you kind of start memorizing as always being soluble, right? Because looking up here, this is the soluble quadrant, right? And these don't have any exceptions to that rule. Nitrate is part of that, okay? So is ammonium, so is acetate, those things, right? So nitrate is soluble, no exception. So we're going to go ahead and say aqueous. And then finally, ammonium and cyanide together, right? Ammonium was one that I just pointed to, and cyanide is also up there, so it's like super soluble. All right, so this one is also aqueous. Are there any questions so far over solubility rules? Any reminders that you need? All right. If not, go back to your notes page, flip it over. Let's look at the back again. Okay, all right. So we started with the back before learning the solubility rules, right? So we had started by using this to show us why we were even doing what we were doing, okay? So just a quick recap. We saw a precipitate is just a new solid formed in a solution as a result of a chemical reaction, as in that is your sign of a chemical change. Okay, a reminder, because when you go to see it in the lab, these, when you first mix them, they look cloudy or they look like milk right away. They look thick, all right? And then at the end of the day, you see that all those solid particles are settling down to the bottom because they were in suspension. It's a heterogeneous. All right, so cloudy or milk, but it is a new solid that does settle to the bottom. So these reactions are often single or double replacement. So I kind of had you guys look at double more so, like circle or underline it. And I reminded you that those were the ones that we called double date gone wrong. And you didn't have to write that if that didn't help you the first time. All right, but if it helps you remember which type it is, this one is the steal your girl, this is your double date gone wrong. All right, so double replacement reactions, as in we have a double, and they make a new double and a new double. All right, that's kind of what we have going on here. All right, a chemical reaction that involves the formation of this insoluble product is called a precipitation reaction. The reactants are going to be soluble or aqueous, but the product formed is going to be insoluble, hopefully, and separate out as a solid, okay? So what I would like us to add to this right here, I just want you to add this little note. Put aqueous, and then put splits into ions. And the reason that I want you guys to have that little note there is because I'm going to remind you what that actually looks like for us. So hold on one second. Let me pull this back up. There we go. All right, so when I showed you of salt dissolving in water, if you remember, all those water molecules were coming and they were taking the ions away from each other, the cations and anions, right? So as it was doing that, what that means is that if the water is surrounding all those, that means they're floating around in that solution. So when we see AQ, that's what we're talking about. It doesn't matter if it's salt or not. That's what it looks like. Okay, so no matter what, we have these ions. They're not together anymore because when they were together, they were neutral. As they are split apart, they have these different charges, and we'll go into electrolytes probably Wednesday. But that's what we're talking about. And that leads us to this whole ionic equation thing, all right? The complete ionic equation and the net ionic equation. So I wanted to make sure you understood that's why we are going to be spreading these all out, okay? So aqueous means that it's split into ions. Anytime you see aqueous, that's what it means, okay? Because they're dissolved in water. All right, so in order to show these reactions, we usually use something called the net ionic equation, all right? And it's going to come from a complete ionic equation, which I am going to have you guys write one because it does show up in your Schoology homework, and I don't want you to be confused as to why it looks so crazy. All right, so a net ionic equation comes from the complete ionic equation. The net ionic equation is really nice because it only shows the ions that react to form the precipitate. Okay, so a net ionic equation is kind of like highlighting what is the main feature, what is the main play of the game, all right? Whereas the ones that are not in a net ionic equation are going to be known as our spectator ions. So spectator ions are left out of this net ionic equation. Just like, you know, when a coach is trying to give you highlights of the game, the coach doesn't turn the camera over to the crowd to say, oh, and then there was that fan, right? I know we all wish that they did that, but they don't, right? So it's only about what's in the game. It's only about that play that they're specifically getting you to try to learn. The spectator ions are watching from the outside. They're not the main event, okay? So that's going to be kind of the same thing here. And this right here is why we have to use the solubility chart to know whether or not we're creating that precipitate, all right? Because we got to know who is the main event. Do we even have a sign of chemical reaction? All right, so the example that we're going to focus our attention on is right below that. It says barium chloride reacts with sulfuric acid to form barium sulfate and hydrochloric acid. And I know we already kind of went through that equation, right? We reminded ourselves what a double replacement looks like. So we had couple. Double replacement means you take the metals and switch their spots. So then we had barium sulfate and hydrochloric acid. Barium sulfate was the only one that had that solid, which is why you guys told me on Friday that was your precipitate, and you were right? Okay, so like I said, I'm going to have you guys write only one of these. So please just write it, and don't worry about needing to do it again until the Schoology assignment where it asks you. So go ahead and label right above the chemical equation, complete ionic equation. And the reason why, again, it shows up on that assignment, and also this is where the net ionic equation is coming from, all right? So what a complete ionic equation does is it uses that idea that aqueous things split into their ions. That's the whole idea of it, all right? So they're very tedious, they're very annoying. When my AP students had to write them for like everything, they used to hate them. But basically what we're going to do is we look at this chemical formula, we split it into its two elements usually, or pieces that make that ionic compound. So for this, barium and chlorine, right, because they have aqueous means they are split into ions. So we would go ahead and put barium, and typically they would have to put state of matter right underneath it, but I'm not going to make us do that. I'm just going to have it for that first one, okay? Barium, and we have to include the charge. So the charge for barium is what? A +2. Then we say plus, and now we're going to say not Cl2. That 2 is going to come to the front, and it's going to be a coefficient because we're saying we have 2 chlorines. Each of those chlorines have a -1 charge. Okay? Then we're going to say plus. Okay, so that's our first aqueous. Now we're at our next aqueous. We have 2 hydrogens and 1 sulfate, so we're going to show that. 2 hydrogens. Each hydrogen has a +1 charge. Plus, and then 1 sulfate. And sulfate has what charge? -2. Good. -2. All right, so those are our reactants split into their ions. Here, I'll zoom in just a little bit more so that way, just in case you need to see it. All right. Excuse me. Okay, so those are our reactants. We're going to draw our arrow. Products. Okay. This one, does it have aqueous? No. So that means that we don't split that one. That one we're going to leave together. So we're going to have BaSO4 and put a little solid next to it. Notice I'm not putting charges on that. That's because when they combine, when they have an ionic bond, that allows them to become neutral with whoever they're bonded with, right? So we aren't dealing with the ions there. Okay? Then we have over here, we have a 2 in front of an HCl. So we're going to have now, that's aqueous again, so we're going to split it. 2H with that +1 plus 2Cl. Oops, not a plus. -1. Okay? And that right there, that is your complete ionic equation. Okay? Now, what you do with a complete ionic equation, in order to make your net ionic equation, is you cross out whoever shows up on both sides. Because what that means is that they weren't part of the actual event, which was creating a precipitate, right? So, Ba with a +2. Is there another Ba with a +2 over here? No. Okay, how about 2Cl with a -1? Yep. So we're just going to go like that, like that. Okay, you're just showing this process one time. All right. 2H with a +1. Is that over on the product side? Yep. So cross those out. SO4 with a -2. No. So what that means is whoever is not crossed out is your net ionic equation. And that's exactly what you see is written for you, right? The ones that we crossed out, those were our spectator ions. Notice, your spectator ions do have to have that coefficient if it was there to begin with, okay? So, so that's our net ionic spectator ions. Are there any questions at least about the definition of those or what they mean? Nope. Okay. Do you see the shortcut so that you don't have to write this whole thing out? Yeah, I see a couple people nodding. Yeah. Basically, you figure out who your precipitate is. The reactants are just what made it. The part that you're going to run into an issue with is if there are an additional subscript, you got to put it as a coefficient. That's the only cruddy part about it, okay? But for this one, it worked out really nice, okay? So I'd like us to kind of zoom through example 1 and 2. They shouldn't take us too long. 2 is really simple. But let's go ahead and take a look at number 1. All right, so we have zinc nitrate, ammonium sulfide, zinc sulfide, ammonium nitrate. So we first had to figure out who our precipitate is out of those two products because we don't know, right? So zinc sulfide. Oh, and just so you don't have to flip it back and forth, remember, green page is a good place to look, right? So zinc sulfide. So I'm going to find sulfide somewhere in my list. Sulfide is down here at the very bottom. Sulfides are insoluble or solid unless they're with ammonium, somebody from group 1, or calcium, strontium, barium. Is zinc any of that? Mm-mm. So it's not. So that means that it stays that insoluble solid. Okay. Ammonium nitrate. Can you guys tell me without looking? Aqueous, for sure. Yeah. Nitrate and ammonium. They're both on the aqueous one, right? So, okay. Now that we know that, who is my precipitate? Zinc sulfide right there. Okay. All right. So, what you do next to get our net ionic? We know that we're making zinc sulfide solid. Hopefully you're seeing that. Oh yeah, well then we just put zinc plus sulfur. Yes-ish, but we got to know the charges. And like I said, that's the part that could get complicated if you don't take the time to look at it. All right, so for sure we know that these are aqueous, so we can at least write aqueous for both of them. Do you know either of those, zinc or sulfur? There is one that's on the guaranteed charges. These are the guaranteed charges. Which one is there? Sulfur. So sulfur for sure has a -2. Okay. How about zinc? So you got two options. Some of you guys still have the orange page in your resource page, but I encourage you to probably not use it because you don't need it. Because if this is a -2, what's the ratio here? You have 1 sulfur, 1 zinc. What does it have to be to cancel out a -2? A +2. That's the answer. Okay. For transition metals, you can always do reverse crisscross, right? Yeah. Okay. Spectator ions. So who are our spectator ions here? I agree. But who is that? Nitrate, but there is a little 2, so what do I have to have? A coefficient. So 2 nitrates with a -1 and 2 ammoniums with a +1. Okay? Okay. Last point I want to make, the one right after it, just so you know, this is K2SO4 on a big 2. Okay? So potassium nitrate, magnesium sulfate, magnesium nitrate. Cool. When you go to look at solubility rules, what you'll see, potassium sulfate, this is a group 1 guy. That's usually in your exception rule. So for that one, make sure that it stays aqueous. Also, it's none of the ones that make it insoluble. So this one is aqueous. And this one has nitrate in it, so what are you guys going to put? Nitrates. Now we're just guessing, you guys. Nitrates up here. Aqueous. Did you say soluble? Oh, you said solid. Okay. All right. Yeah. So this one is aqueous. So if you notice, we have 2 aqueuses. Do we have any indication of a chemical reaction there? No, there's no precipitate form. So unless we were looking at it in the beaker and we saw that, oh, it got hot or something like that, or made bubbles or something like that, right? If that right there, just looking at this chemical equation, there is absolutely 0 sign of a chemical change. So what we write is no reaction, because what you just did was you mixed 2 liquids that everybody was already split into these ions, and then now that's just more ions that are all split up, and it's just nothing, and you didn't do anything. You just mixed 2 liquids, and it's not. You shouldn't be proud of that. I'm just kidding. You can be proud. It's fine. Just kidding. All right. So no reaction there because they're all soluble, right? So they're all ions. Whatever you want to say. All right. So that was the point I wanted to make. We'll save 3 and 4 to start us tomorrow, get our brains going. And yeah, okay. So on Schoology, just so you know, you guys have these 2 assignments are showing up. Terminology was one that was assigned last week. That one is saying that it's due tonight. Okay? So you might try to knock it out, put your attempt in on that. This one, solubility rules. This is based off of the notes we just took today. Okay? So I would work on that. And I wanted to point out in the folder, our Unit 9 folder, You guys have a Friday, Monday folder. That is all the solubility rule stuff. If you've been out along the way, please make sure you go back to whichever folder you need to go to make sure that you got what you needed to get. Okay? And that's all I've got.